Okay. Sorry about that. All this graphical stuff is confusing me. So, first off, thanks to everybody for coming to Scale and sticking around to the very end. It's awesome. I certainly hope everybody's enjoyed Pasadena. I've definitely enjoyed the new location and gotten lots of good feedback about it. So my presentation is Anatomy of Command Line. So we're going to talk about what order things take place in Bash and Shell so that we can avoid certain surprises because things happen in a different order than they would look like they would take place. We're at scale 14x and all that. All right. So I've got a couple of caveats. I'm skipping some of the pedantic details for the sake of time. So if you think of things and you say, hey, there's these 14 edge cases, hey, go read the man page. All right. I'm presuming you're already familiar with shell features such as pipes, redirection, variable expansion. This isn't a full thing on shell. If you want that, actually go look at my scale presentation from like 8 years ago. Or read the man page. And then also, I'm going for clear examples rather than better code. When we teach programming or teach many concepts, you have to go for the thing that's going to point out what it is you're trying to illustrate what you're trying to point out, and that is oftentimes not the way you would do it in reality. The whole physics thing where go find the round cow, right? If you can get a round non-variable density cow, that would be, yes, much better for production, but it doesn't really work so well in the real world. Yet, I'm certain somebody's working on it. All right, so let's dive right in and talk about ordering. So the shell, when you type up a command line, is going to go through and parse that and do certain things in a certain order, and certain types of actions happen first, and some of them happen last. So let's talk. The very first thing that happens is redirection. That is the very first thing that takes place. Then you have pre-command variable assignment. We'll get to what that is because it's kind of funky name. And then we have expansion, the things that we often think about as happening at the shell level, and pipes. And then at some point you get to the commands. So you can see there's a lot of things that actually happen before you even start the command up. So let's talk about redirection first. So this is ripped from last week's headlines. Some of you might recognize these examples. So echo, oops, getting a line ahead of me. Don't look. If you saw that, forget it for 60 seconds. All right. So we had an SSH vulnerability that why that was in there, but anyway, still a fan of SSH, but that one they owe us an apology. All right. So there was a configuration change you could make while we were waiting for package updates to come through, and you could disable the undocumented configuration option. Brilliant. In your SSH config. Now you can change that in your personal config, and that will change it for your account. But if you're wanting to change it for the system, you need to go through and do that in etc ssh _config. So on this particular command, can anybody tell us what will happen when you run this command? Yes, sir. No. So first of all, who's running the command? I'm not giving you a shell prompt, so I am kind of cheating. But if I'm running this is me, what happens? You get an error because you have permission denied, right? So now we all know sudo, right? So I can sudo, hey, this is a live presentation. I can change things, right? So I can hit sudo and echo that out, and that will give me root permissions when I run the echo. Does that solve the problem for me? No. The redirection happens before the sudo is even looked at. Redirection happens first. So the redirection is still taking place as me, not as root, even if I'm using sudo. So let's go ahead and, need to be able to see what I'm doing. All right. Whoa, that was not what I want. So kind of protecting. Oh, oops, sorry. Forgot one part of the setup. A couple of people in the room understand that. And this is important for a later piece. There we go. So permission denied. Because as me, I do not have permission to change that. And if I sudo, it didn't even ask me whether or not for my password, right? I don't allow myself to just randomly run things as sudo. It didn't even get to the point of asking me a question because it didn't have access. All right, so we can instead use T. So what does T do? T takes output and splits it to standard out, so back to your terminal, and also to a file when you give it a file name. So if I run T under sudo as root, now T as an application has root permission in order to open up the file. If you are doing this, remember the -A in this particular case, so that you append the new configuration option instead of wiping out your previous configuration, which is probably not good in the case of SSH. And you can then have access to it. So this is a good illustration of how redirection happens first. As I say, the redirection happens before whatever command you want to run even gets looked at. This is from my talk, the talk description. And so if I echo Anka into the file, I'm truncating, single greater than. So I've created a new file, or I've emptied a file, and oops. I try not to leave stuff all over my home directory. So I go through and echo that in, and I'm creating a new file in this case, which is a brand new directory, and I am then checking to see whether or not the content made it into the file. And then in this one, I'm going to again create truncate the file, add the content to the file so we know it's in there. I'm going to grep for it, and then add the part that didn't get copied. Again, grep for the content. So I know that that content is in there, and then I'm going to take the output from that command and put it back into the original file. I get an error. That's what the frowny says. Tells me it didn't work right. And my file has 0 bytes. Because what happened in this command was that the grep anka redirect into the file, the redirect truncated the file before the original grep happened. So the first grep for grep anka file.txt was actually reading an empty file, because the truncate happens first, then we go find out what commands are going to run, and they start doing things. So by the time the grep is instantiated, the file has already been empty. And then, since this is getting too long, cheat. And so this one, I am going through and again creating the file. This time I'm grepping, and then using T to open the file. So the first thing that happens isn't the truncation of the file. T goes through, and I'm not using the append, so T will truncate the file and then add the new content. Now I'm cheating a little bit, and we'll see that later on. But for right now, leave the guy behind the mask or whatever that is, okay? All right, and all right, make that a little bit cleaner. Oh. the heck just happened? Block. There we go. All right. Now in this case, I'm using a subshell. We'll get to subshells later on in order to do something. So as a result, we have the echo foo is going to append into the file. But we still end up with an empty file. So the let's take some of that. I don't need to do it. So the echo foo goes into file.txt, but that doesn't leave any output that the outer echo is using. So we truncate the file, even though we've added content in there. And here we get the contents of the ls coming into the file. Because what happened was the echo foo is into the file, produces no output. And then the ls-l output is echoed by the outer echo into the file that's been truncated. And now, pre-command variable assignments, I used that when I set the lang. We'll give an example for that. So lang equals C. You saw me do that. And what that is, the shell looks at variable assignments. Oh, yes, sir. Sure. It has the results of the ls command. Yeah. So, okay. When prepending a variable, you can see from the next example that I can prepend a variable and set up a variable for a particular command. And we'll get an example for that. But with the shell, looks for variable assignments before it goes through and evaluates the command. Again, that was the second item and several other things before we actually get to the command. Looks for those variable assignments. If you have just a variable assignment, such as lang equals is assigned C, then it stops and it doesn't issue a command because there's no command to run. There's a couple for the pedantics. Go read the man page. There's a couple of extra pieces there. So in the next example, though, I am using that assignment in two different places so you can see that the variable assignment is taking place. And a key for this is that this example actually doesn't show it as well as I want. But a key for this is that variable assignment is only for the particular command. So if you do the variable assignment on the same command line and then have the command afterwards, that variable assignment does not actually impact the shell. It is just for the command that is being run after that. I've got the whole thing. And yes, I intentionally had errors so we could see that the results from both the commands. Also notice that I'm not getting the output in the order that they appear in the command line. So we got the output from behind the pipe before we got the output from before the pipe. So the find is looking for a directory that doesn't exist. I had preset the language environment to be German. We get the error output in German. For the sed, which is also an error because it's a illegal operation, but I'd preset it to English and we get the result, the error output in English. And then I wanted to show again that the redirection happens first. So here I'm assigning, using this variable pre-assignment, to assign a value to a variable, and then I'm using that variable as if, the value of that variable is a file name. But because the redirect happens before the variable assignment, I'm trying to redirect to null. And you can redirect to dev null, but you can't just redirect to null. All right. Next is expansion. I call this a 7-layer burrito of the command line. You have a whole bunch of different things that all happen at the same time, and they kind of get intermixed. Like the pieces of when you're chewing on them. Anyway, so the 7 forms of expansion. I'll give you this in a little bit better form in a second. Are brace expansion, tilde expansion, perimeter and variable expansion, parameter. Command substitution, arithmetic expansion, word splitting, and path name expansion. We'll go over what each of those are. The order is brace expansion, then tilde expansion, parameter and variable expansion, arithmetic expansion, command substitution, which is done on left, right, all happen at the same time. So whatever order you find those in, you do them at the same time. So it's kind of like addition and subtraction. They have the same. They happen at the same time. It's which one do you run into first? But you have multiplication, division, which take a higher priority. So these all take the same priority and happen in the order encountered. All right. Then we have word splitting and path name expansion. All right. And then we have a bonus layer called process substitution, which takes place at the same time as all the other things take place. And process substitution, we'll get to that. All right. So tokenizing. This is from the bash man page. Only brace expansion, word splitting, and path name expansion can change the number of words of the expansion. Other expansions expand to a single word. So if any of the other expansions, so brace expansion, everything, get back. So brace expansion, word splitting, and path name expansion can change the number of items on the command line. Other types of expansion don't. They might have spaces in them, but it's still a single item. And then there's a later expansion that goes through and tokenizes based on whatever your IFS is. And we'll cover IFS. Don't change it, but we'll cover it. All right. And as I say, that's directly from the bash man page. Brace expansion is a bashism that is not in the traditional Bourne shell, but we use it a lot. Left to right order is preserved. And I'm going to give you some examples. So in this case, I am taking nothing and /user and $home, the value of $home, and local or the value of $home / local and user local, and splitting those out into different pieces as expansion and combining them with nothing and s and then with bin in general. So that short line gives me all these different directories. Basic word. You might guess where I use this in my profile, but I can then shorten what it is I need to keep in there and make it easier to me to organize. So let's take a smaller example of that that's a little bit easier to parse, to human parse. So again, in this case, I'm taking nothing and /user, followed by a slash, followed by nothing and s and bin. So nothing and slash and nothing and bin gives me /bin, and nothing and slash and s and bin gives me /sbin, and then user and slash and nothing and bin gives me user bin, and user and slash and s and bin gives me user sbin. We can also confuse ourselves in the mid-presentation, sorry. We can also do sequence expansions. So this is saying 1.10 says, give me 1, 2, 3, 4, break up 1 to 10 and give me each of those as an item. And we have a couple more pieces with that. This is an example of... So first of all, anybody want to tell me what we're going to get as a result of this command? We're not going to get the same thing as before. So what happens first on that in that echo command? So it's going to try to do this brace expansion first before it does variable expansion. So, right? So we get 1 ... and a variable, because brace expansion says I don't know how to expand that, so it leaves it in place. And then later on, you get the variable expansion, and so $10 becomes 10. And then, oh yeah, there's a command you wanted to run, echo. Let's spit that out to the terminal. Somewhere, some shell, I thought they had it in Bash for a little while. There's a way to actually get the variable to happen first, and then it went away, and it got confusing. But generally, brace expansion first, and it makes it kind of annoying. So you do have to switch to actually using a loop or EXPR or something like that if you want to build a sequence. Now, we can nest them. I'm just going to go through a couple of these somewhat quickly. Oops. I'll go through them quickly if I actually copy them. We can use alphabet. Oops. Yeah. And we can skip. So this one's saying, .2 is saying, give me every other. You can do .3, and so forth. All right. So tilde expansion, parameter and variable expansion, arithmetic expansion, command substitution, and process substitution all take place at the same time in the order encountered. So for my 7-layer burrito thing, I count these as the squishy things. So these are the things where they all get mixed up, and as you bite into it, you never know what you're going to get. All right. And of course, salsa and sriracha are important parts of a burrito. All right. Okay. And as I say, they might be intermixed as you're going through. So tilde expansion, I'm just going to cover these briefly. Tilde expansion says, look for a user with this name. If you don't give a username, then it looks for your home directory. Actually, this example I did want to do. But without leading dot. Oh. That's why I took it out. It was too much output, sorry. So, there we go. So it goes through and expands each of those. So we get the brace expansion on var log and cache, or lib log and cache, excuse me, and then we get the tilde expansion on each of those directories. All right. And then tilde plus and tilde minus, this is actually new to me. When I was getting ready for the presentation, I was like, oh, really? So if those of you know that $dir is what directory, or $pwd is what directory you're in, and $old pwd is the former directory, wherever you've last come out of. So tilde minus is a way of doing $old pwd, And the $+ is a way of going to the next directory, which if you haven't been there yet and you don't have a time machine, but it's, so no, for if you use, there's a way of doing a directory stack. I don't ever use it, but there's a shell way of doing a directory stack, so you can go up and down that array using plus and minus. And then the dir is the directory stack. I say beware the use in scripts, because there are places where tilde just does not expand or doesn't do the way you want it. So generally, use $home is my recommendation. Yes, it's more typing and it's rather annoying. We've got this perfectly cool tilde up there. We don't ever get to use it, except for when we accidentally hit it when we were trying to hit escape because we use VI and but beware use of it in scripts. I recommend using $home or pull if you're trying to get into somebody else's home directory, use other tools to go through and expand to that. All right, parameter expansion, variables. Good engineering documentation is like legal documentation. They take the native spoken language you're using and use it in a different way to make it confusing. So, all right. So parameters are variables. There's actually more that you can do with parameters. There is more than just variables, but for the most part, that's how we think of it. So one of the things is there's lots of fun string manipulation that can be done during parameter expansion. Before I get to that, I taught at a community college for 7 years. And two things. If you ever teach, don't teach globs one night and regular expressions the next night. Your students will be in the hospital. It's not good, right? They're two different languages using a similar character set, but not the same, doing different things. And it's rather confusing. The other one is the string manipulation. If you teach them a bunch of these all at the same time, they get intermixed. And so I find if you're not familiar with the string manipulation, go look at one, play with it for a little while, get used to it for a couple days, and then go play with another one. I really recommend doing that, so it makes it easier for you to understand them. And that's how I learned them inadvertently, but I found that it's useful to do that. The problem with finding them is that the bash man page is kind of like the length of War and Peace with an encyclopedia added to it. So it takes a while to get there. It is actually, there's a very nice shortcut that works directly for these. If you search for :- in the bash man page, that will take you down to the string manipulation portion of the man page. Excuse me while I go Rubio on you. All right. And then the other piece is that this, as it turns out for this presentation, most of it is from like 400 lines of the bash man page in the end, because it describes it all more tersely than I am. So if you end up with the : you're kind of in the middle of that. So that puts you right into the main portion of what I'm covering in the presentation. All right. So command substitution and subshell. These happen at the same time. They're kind of the same thing, but not quite. And we'll cover that. So they are a copy of the current environment. They are not a brand new shell. I call them the turducken burritos. You just keep shoving more things in there, right? And that's a reason why we don't use an old mechanism. We'll get to that in a second. So first is command substitution. It replaces the command with results of the command. So if I use command substitution to say echo Fred, what ends up on the outer command is Fred. Whatever. So if I do an ls, the results of the ls end up there. If I do a find, if I do, go grab some random Wikipedia article via curl and put that to standard output, that all ends up in place in the command line. The mechanism for doing that is explicitly and only this, and I'll cover why it's not something else in a second. So $open paren, whatever command you're going to run, and close paren. You can have extra spaces in there because we're not Python, we don't care. But it is, use this, and the reason for it is by having a left and right that is not the same, we get nesting. So I can do command substitution inside a command substitution inside a command substitution, and I don't have to do any funky things in order to make that happen. I can just use it. And most of the time you don't, because you're doing something kind of complex at that point. But once in a while, it's rather advantageous to have that. There used to be and officially it still works, but I tell my students it doesn't. There used to be a mechanism for command substitution using backticks. The problem with backticks is they look like front ticks. They're just, in some fonts, they're just vertical lines. I'm like, is that a quote or is that a backtick? I don't know. And for those of us that are like needing to get, bigger and bigger things so we can see stuff, even if they are different characters, they're looking more and more like the same blurry, fuzzy thing right there. So they're bad because they suck for readability. But the other is, you have your left backtick and your right backtick is the next backtick. So if you want to nest, you now have to start quoting. But when you quote, you have to quote your quote in order to quote your quote to get to your backtick. And yeah, the time it takes you to figure out how to do backticks, you could have like created a new programming language that doesn't have the problem and written in that programming language. So avoid backticks because they're unreadable, they're a pain, and they don't work very well for nesting, and it becomes uncertain what it is you're trying to do. If you've got scripts that have backticks in them, please replace them. Right? They're pretty easy. You take one backtick, you take the other backtick, you put in 3 other characters, and they're gone. It's beauty. All right. Backticks aren't readable. Nesting doesn't quoting nightmare. All right. Subshell. So subshell is like command substitution, but we took the $sign away. So there we go. Subshell. All right. So we create a new environment that doesn't change the parent environment, just like the command substitution. The difference is that we are no longer taking the output and putting it in place. We're just kind of running a subshell that's doing stuff, and the output doesn't come back into the current command line. In both cases, you can run multiple commands within that setup. I think I've already used it. We will use it later on. Note from, I should figure out where I found this. I think this was in the Advanced Bash scripting guide, but there was a point that inputting using redirection from a file is faster than catting the file because you don't have to start up another process. So I will say though, and I put this in I used to teach a shell scripting class, and shell scripting is important for sysadmins. We should all know how to do it. We should be able to do it really well. But at the point that you're caring about efficiency, you should probably be looking at a different language. Right? Shell is not the most efficient thing out there. We can do a good job with it, and there are some times when we need to use shell and we need to be somewhat efficient. And as much as I love it, I will agree that if you really, really care about efficiency, let's consider something else. All right. Now, if the substitution appears within double quotes, word splitting, path name expansion, and path name expansion are not performed on the results. So even though it has spaces or whatever your IFS is in those results, it is quoted and becomes a single string, right? So if you put echo, quote, hey, space there, quote, that hey there with the space in between is a single string. Same type of thing. All right. Arithmetic expansion. We can do math. All right. But we cannot paste. Boom. All that to figure out 4. Sorry. But an important part is that it is integer only. This one I'll just cheat. Syntax error. So shell doesn't get floats, doesn't get decimals. And it can lead to fun. So what is, oops, wrong thing. What is the result of this particular math problem? 1. So you end up with 1 and a remainder. So I can also do that and see the remainder, but I don't get both at the same time. There are other tools that allow us to do that type of math. You need to go to those if you need to. An important point of this is that the expression is double quoted. So when you're doing your math arithmetic expansion, we don't have any quotes in here, but it is quoted. So I don't have to escape my star when I want to do multiplication. All right. There used to also be a square brackets syntax that is deprecated and will be going away any time now for the last 15 years. So who knows if and when it'll ever go away, because there are shell scripts that were written in sometime in the late 80s and nobody's going to change them for some reason. But so don't use it though. You might see it, and that's why I put it in here, just in case you look at it and go, what the heck? Hans didn't mention this. Well, I did. But don't use it. All right. Don't use it for anything new. You can do nesting. So we can do, so we get 3 plus 3 is 6 and all that. A double quote inside an expression remains a double quote because you're quoted, so it doesn't get changed. Parameter and variable expansion, command substitution, and quote removal happen within the expansion, within the arithmetic expansion. So I've assigned a variable, and then inside the arithmetic expansion, I'm using the variable. That gets expanded to the value of the variable, and it is used. Still has to be a valid integer or valid number for it to work, but it works just fine. All right, and we had a couple of security talks over the weekend, so I thought we'd put a nice example for that in place. There we go. Oops. There we might go. Oh, yeah. You still have to have valid syntax for some reason. Okay. All right. So we can see we've got that in there. I've got variable expansion taking place, a couple different things. Again, and here we're highlighting priorities. So the multiplication happened before the addition did. Standard arithmetic as far as that goes. Yeah. Oh, yes. I did this because 1948 was when he wrote the book, and so that was the excuse I gave for my typo, and it still works. All right. So, and it is sure. So he came up with 1984 because it was the opposite of like the published date or whatever, something like that. So process substitution. This is the fun thing we get. Other operating systems do not get it. We being, I'm presuming we're all using Linux, FreeBSD, etc. So we get it. Other lesser systems do not have this option. And I never really use it. There are a couple of edge cases though where it is quite handy. I usually just cheat and use a file. And that's what I'm going to use for my example because again it makes it easier. But there are times when it is nice to be able to look at two different things without having to reach to the file system per se. So this first one, I'll actually do it this way. So first off, what happens after the hash? It's a comment. So it's a comment in the shell script. It's a comment on the command line, right? In fact, if you are working on a command that's like rather long and convoluted, and you're like, oh, I got to stop and do something else, insert a hash in front of it. Now you have a comment in your command history, and you come back to it, right? Or you've gotten a late night call, you're root, and you're doing stuff, and you're like, oh, I was drinking a lot. Maybe I'll just copy this for somebody else, or get to it in the morning when I'm sober again, right? Okay. So hopefully you're sober in the morning. All right. So this is showing you the pipe name pipe that's being created for the command substitution, and then the next one. Oops. Whoa. Is not going to work unless I actually copy it. There we go. So I'm grepping for sources.list from the output for the find command. So you say to yourself, well, you could just do find and then pipe to grep. But then that wouldn't illustrate what I'm trying to show you. But yes, normally that's how I would do it. And as I say, this is useful for a place where you need a file, but have standard out instead. And I really should capitalize standard out because just that's normal. Yeah. All right, so I will now use an example where it actually makes sense. I'm creating a file. And diff doesn't like files, or doesn't like non-files. Diff wants 2 files. And whatever you do, it says, no, give me 2 files. I want 2 files. I will accept only 2 files. So what I'm going to do is give it 2 files. It's just that the second file isn't really a file, but diff doesn't know that. And so this is where we're using command substitution. And we get that the only difference is the file I created when I was reading the file system, because it's looking at the same thing. But there are lots of times when you have a more complex comparison, especially you might have 2 different file systems that you're comparing or something like that. And it is handy to be able to feed diff output from 2 different commands and get it to do the diff on the fly without having to wait for a file, or without having to throw them into files first. All right. And this is another place where it's useful. And so let me get the syntax correct first. So the issue here is while is awesome, but it is a subprocess. So whatever happens within the while stays in Vegas, and you don't get to find out about it. So normally, if I go through and assign, so in this case I'm assigning 1984 to I, and then I'm saying, I really screwed that up. Okay, so I'm taking 1984, I assign it to a variable, use it within the while because it exists before the while. Then inside the while I do things to it. After I get out of the while, it returns from the subprocess, and I come back and scope to the original scope, and whatever happened in the while is gone. So for instance, if I go through and grab the file sizes for all the files in a directory and use while to iterate through them and add them up, and I get a total, and then after the while I say echo total, I get nothing. Right? What I usually do is as I'm going through the while, I echo out the lines every time, and then after the while, where I've got standard out, I pipe to tilde at -1 and get just the last entry. But now I've echoed out a whole bunch of things and stuff, and it's rather annoying. But by doing process substitution, or the redirection, I can now actually get my content after the while because it changes where that subprocess is. So in this particular case, I instantiated J inside the while, and all I did was add to the I, and then I went through and got the result at the end. Now there's a couple things that I didn't add to the presentation that occurs to me I should. First of all, I did ++I instead of I++. Why did I do that? Yeah. So we got here. So I'm adding to the number and then assigning to J. The other way around, I'm assigning first and then doing the addition. So if I do I++, I assign 2112 and then increment I and throw it away. So I don't get the increment. The other part is, notice that I left the $sign off inside the arithmetic expansion. In the previous examples, I could have actually done that as well. The variables will be expanded even without the $sign. So, and I really should have done it the right way up there, but they both work. Yes?
So when you did the hash mark in front of the command and put it into the history for reference, if you do like an up arrow to bring back the command, how do you make the cursor jump over to the beginning of the screen?
Okay, so it depends on which editing mode you're using. I use VI, so I start off back at the beginning, right there to begin with. If you're using the default syntax, which is Emacs style, I think you end up there, but I don't know because I don't use Emacs. Control A? Control A, there we go. See, and that's another reason I don't use Emacs. Control A does things in screen. It would mess up my day. And and I use screen a lot, as you can see. But anyway, yeah, so learn command line editing, look at libreadline is where all the documentation is inside the man page. If you search for readline, the word read and the word line concatenated together inside the bash main page, you can find out more about editing. And of course, there are many guides and how-tos online. All right. Word splitting. So we've split on text that is not in double quotes. Again, if we double quote, we protect that. It uses the inner file separator. And by default, that is space tab and something else. I think new line. Don't change it. You can. It's a variable. You can assign to it. You can assign Fred to it. Don't, please. Because when you do that, you start getting other behavior effects. That affects everything. And those of you that know what you're doing, yes, you can do it safely, but please don't. There are other ways of handling it in most cases. If you do play with it, make sure you keep an original copy of it so you can set it back, and ideally do it in a subshell so it goes away, and other things. Because forgetting about it, you think, oh, I'm done, and the script ends, and you don't reset it. And then later on, you go add things to the script, and if you're doing that as root and you wipe out your file system, you'll have removed your evidence that you did it with the IFS and never figure out what happened. So don't mess with it. And then the example I give here. So what happens with that is that the echo sees the string of file space file, but it doesn't see, they're just letters and a space and letters. Echoes those out, and then the word splitting takes place, and ls is given 2 arguments. ls is given etc issue and etc resolved conf as 2 different arguments, but it's taking place at the, as I say, the else or in the shell. All right. Path name expansion. Globbing, right? So I mentioned earlier globbing, regular expressions. You should know what globbing is. That takes place at this level, and all the different things you can do for globbing. We'll leave examples out. Then you get to quote removal. So the shell just says, oh, there's quotes. They're gone. Okay, they just go away at that point. So again, you can see by knowing when quote removal happens, what pieces are impacted by are protected by quotes and what are not. We finally get to pipes. Right? So we did redirects, and I kind of teach they're like pipes, but they're not really like pipes. They are different places for the shell. So we get to pipes. What haven't we gotten to yet? We haven't even got to commands. All this stuff, we haven't ever found out what it is we're going to run. We haven't found out what we're going to run, and we got to pipes. What do pipes do? Allow us to run multiple commands, right? Take the output from one command and make it the input for the next command. Not necessarily in that order. Pipes, all the commands in the pipeline fire up at the same time. If I find and pipe to grep, find and grep start at the same time. Okay, yes, for those of you that do kernel stuff and everything, something fires up first. However, from our perspective as a sysadmin writing a shell script, it's indeterminate which one comes up first. And I'm not certain that there's actually a determinate way to figure out which one comes up first. And that's why my example early on with T instead of the redirect, I was cheating. Because potentially the T happens first and I end up with an empty file in that particular example. So, which caused the first time I gave this presentation to not go very well because I was like, what the heck? But it's a good example that I need for that point in the presentation. But don't count on it, because again, that T could actually be truncating that file prior to the grep taking place. All right. So this error that I created before gives us a good example of, what the hell did of what happens. So, let's go. First of all, if you remember before, We got the error from the sed first, and then we got the error from the find. This time we got the find first, and then the sed. So most likely could just be the time it took for the errors to come out and so forth. But there's most likely they actually fired in the opposite order as they did before. And so if you notice with that, the sleep is the first command, but we got errors from the other two commands before the sleep completed because they all fire at the same time. The other two commands weren't actually dependent on the output from the sleep, so they were able to do what they do. So when you use a pipe, they're all actually happening at the same time, and all the stuff that we've covered before happens in there as we're going. All right. And and just to show that standard out also takes place. That's why I did the LS at the issue. We got standard out before the sleep completed. So again, it wasn't just that error came up quickly. All of them fired at the same time. Command! Woo! We get to do something! So the command or equivalent, again, for those of you that are pedantic, go have fun with the man page. We're gonna do this stuff. So functions and aliases, they're commands. They aren't. So if you're using functions and aliases, you need to know what those are and care about them. But from where we are right now, they get evaluated at the same time. They're the same thing. And I'm not going to cover what functions and aliases are. So, regular expressions. What shell construct uses regular expressions? Grep. It's not a shell construct. Still, that's a separate command. It's not a shell construct. There are a couple. So the string operators that I mentioned earlier for string manipulation, there's a couple of those where you can use regular expressions. But as far as the command line goes, shell doesn't look at regular expression. Those get passed on to the commands, and then the commands use regular expressions, right? So there are a couple places where you can use them, like I say, for string manipulation, a couple of other isolated things. But if you just have bare regular expressions on the command line, what are they? They're globs. If you just have a bare regular expression sitting there on the command line, the shell is going to look at that and go, hey, I know what these characters are. A star looks like a glob to me. And it's going to try to use that as a glob. So if you're going to use regular expressions, you need to quote them. Even if the particular one you're doing right now is going to be just fine, you need to go through and quote those so that you can make sure that they are protected for that command and they are not being turned into globs. There we go, sorry. All right. Thought my phone was doing things and I don't want to pocket dial like Secret Service or something. Yeah. I was not at the security talk. I have no idea what you're talking about. Oops. And if you paste into the wrong screen session, it doesn't do what you want it to do. So just go back to the other way. So I'm creating a file. So a file, was that correct? No. I'm creating 3 files. f.1.txt, f.2.txt, f.3.txt. So I'm using base expansion to do that. I am then going to hopefully copy the correct line. Truncate file.txt again. I really don't like that file apparently because I keep beating on it. But I'm throwing FFF in there. And then next, I have created my convoluted environment. And I will take advantage of that. So what's the result of this command? Nothing. We know we have an F in that file. grep is looking for an F in that file, but it's not. We get nothing. So how do we tell why we got nothing? We use a print statement. So in the case of echo, echo is just spitting out whatever the shell told it happens after the echo, right? So what we end up with is echo gets the plain text that the shell interpreted and handed off to the echo. And the shell saw the f dot star as a glob and said, hey, do I have any files that start with an f, have a dot, and then something else? Or nothing else, as the case could be. And as it turns out it does. So what happened with that grep was that grep got grep f.1.txt space f.2.txt, f.3.txt. It did not see a regular expression. It saw the results of a glob. So if I want to use the regular expression, I need to protect it with quotes. All right? And we have 3 types of quotes. It's not part of my presentation, but hey, we're here. What are the 3 types of quotes? Single, double, and character is the way I list it. So, backslash. If you're using backticks, you need your backticks to do quotes, but you need a backtick, your backslash in order to get a backslash. All right, so please don't use backticks. All right. Single, double, and character. So the backslash quotes the very next character. So let's go back down here. And if I wanted to have 2 stars here for to break my regular expression, I can get them one at a time, right? So there's a single character quote. If I want to have a backslash, I need to have 2 backslashes, because the first backslash says, hey, the next backslash is actually a backslash. And when you do backticks, you need to backslash your backslash to get your backslash. You end up with 3 of them per level. Don't do that. All right. And I think I did these examples. Graph F. Okay, further examples. There's a grammar issue right here because I have further example because I took most of the examples and put them back up into the presentation. But I have one nice example. That is longer than the screen. Oh, that's going to be fun. All right. So we're going to have to make this slightly less readable in order to have room for it. There we go. Ooh, there we are. Okay. So first of all, what does this do? Something I needed to do the other day. Actually, somebody in the room might actually kind of recognize what it was, I think, right? Oh, no, good. I removed enough details you might not recognize it. Good. All right. So I had a text file with some content in it that was somewhat standardized, but there were other pieces of content in the file. So I needed to find the lines that had content that matched a particular regular expression. I then needed to iterate over those lines, and I needed to iterate over those lines and grep again for them in the file and do a count of how many of them were in the file, and then I needed to sort them in a particular order in order to get them. And while there were probably easier ways to do it, I built this up like we often do as a sysadmin. I say, okay, what's the first part? I go tackle that first part, and then now how do I do next to the part? We have pipelines. We can do these things as pieces and glue them, put them together like Legos, except for when you're doing Legos, you're like, oh, where's that piece I needed? Oh, they don't actually make it. I can make my own piece. It's awesome. All right. But it gets kind of, hectic. Anyway, so I need to do all these things and go through and do that. And so this command is a little convoluted, to say the least. So let's talk about what happens in what order. So first of all, what's the first thing that happens? The redirection, you would think by watching my presentation. But actually what happens is the subshell. So that first parenthesis, because the redirection takes place at a different command line inside the subshell. So the first thing we get is the subshell. We're going to do a whole bunch of things, and eventually we'll get to the pipe. Don't forget the pipe. It's a song about a pipe. Oh, that's it's a different thing. Sorry. So we'll get the subshell first, and then within that subshell, we have things happening. So we can go through and look at it, and the next piece should be the redirection. I hope so, because that's what I'm going to say. All right. The next piece is the redirection and the process substitution. Now, notice that we're actually getting both. I didn't cover that very well earlier. We have a less than, a space, and another less than. The first less than is a redirection. The second one is the process substitution. So we're taking process substitution, and we're using that to redirect standard input for the while loop, which totally makes sense. Yeah, but it is how it works. And I don't know who figured it out and how long they'd gone without sleep before they, that made sense. I have that. And that will get in to the while. Inside the while, we're going to grep so the process redirection is going to give us the grep that is looking for the A to Z, followed by another A to Z with a space in between. Then from file, we're sorting those to unique. -U says give me unique options of those, because I don't want, if I have 50 copies of the line in the file, I don't want to search for it 50 times. I just want to search for it once. So I'll take those unique things. And where are my... So that is... Okay, oops. Oh, all right. So that is where the first parenthesis in Subshell ends. So I was reading it wrong earlier on. And then we take that, throw it into the while. We read each line into a variable called name. We do the subshell, take the values of the results of the process substitution, assign that to count so that we can get that. The problem with doing it with count and then echoing out, I just get a number, but I don't know which thing had the number. So I also need to go through and put that in there. Why the hell do I have a lesson here? All right. And get that. Then, why do I have a lesson here? Should be a cat or something, maybe. All right. We have the other. Oh. Okay, I know why. Because at some point I middle-clicked in the middle of my file and totally messed up my example. So sorry about that. It still gives me the pieces I was trying to point out. So we get the process substitution, the redirection, we get into the while, and get our unique counts. Then I go through and echo the name with the count so that I get both of those together. And then I can go through and finally sort them numerically in reverse and then get the extra less. So yes, at some point, sorry, I pasted itself inside of itself and made a turducken mess of my example. So my apologies. I will fix that and get them to upload the actual example so that we can have that online. All right. Yes, sir. That was just a file. And that was pasted in the wrong place, apparently. So, yeah, I have to, this is totally not what I've, yeah. The redirect with the grep and everything, those were the pieces I had, but as I say, I've obviously pasted it inside of itself and mangled it pretty badly. Resources, Bash man page, I mentioned it several times. It's a great resource. It's long. Don't try to read it all in one sitting. Break it out over different periods like years. No, but it's a great resource. It has a lot of information. The thing that it doesn't have too much of are examples. So for that reason, I like to look at point people at other resources. A very good resource is the Advanced Bash Scripting Guide. Has a lot of examples. It's somewhat disorganized in many ways, but it is still a great place to go look for stuff. And of course, once you have keywords that you're looking for, you can